Writing a function rule is really similar to what we did in the beginning of the year of translating words into math, probably one of the first or second lessons that we did. The difference is these rules, these equations are going to be functions, meaning that you have an independent and a dependent variable. So our target is that I can write equations that represent functions. Key right here, this is the how-to. Writing a function rule is simply translating to an equation with two variables. Those two variables, one is the independent variable, the other is the dependent variable. So let's take this right here. Capital C, C is 8 more than half of n. Don't really have a real life scenario with this, but you see that we have two variables. We have C and we have n, and some stuff is happening to it. The C is going to be 8 more than half of n. So let's start by translating each of these. So C is simply C. And if you'll remember when you were taught this, at least by me as a 7th grader, I would teach you to kind of translate above, or in this case we're doing it below the equation or the sentence, and then piecing together the order of how all these things relate to each other. Is, that's your equal sign. 8 is 8. More than is going to be adding. Half is 1/2. The word of means multiply. I didn't put x there because I didn't want you to think it was a different variable. And n is n. So when you go to piece this together, C equals 8 more than half of n. So you're going to need to put 1/2 and n together, showing that they're multiplying. In algebra, I can just put that in right there by 1/2, or I could have written that as n divided by 2. Either way, but that order will definitely work. Or if you want to put it in standard form, put the term with the variable, which is going to be 1/2 n, in front of plus 8. And if you do, that's what it will look like. C equals 1/2 n plus 8. Like I said, you could have put n divided by 2, and that would have meant the same thing. If you had parentheses around there or a multiplication sign in the middle, I recommend that you remove those, because in algebra we want to shrink it down to as few things that we're writing as possible. So here's one with a little bit more real life to it. The height f in feet of an object, when you know the object's height h in inches. So both things are relating to height. The difference is one measurement is in feet, like let's say you're 6 feet tall, then you would be 72 inches. Keep in mind that your dependent variable, your output, is what needs to be isolated. And then your independent variable is what the rule is working with. That's your input. So let's put on our thinking cap, and when we have on our thinking cap, we're thinking, oh yeah, 12 inches equals 1 foot. So we would use this setup right here. However many inches tall something is, you're dividing it by 12, and then that's going to equal your feet. So keeping in mind that your output, your dependent variable, that's going to be feet. The reason that feet is dependent is because that's going to be dependent on how many inches there are. I'm wanting to know feet, so feet is isolated. And so as a function, that would be f equals I over 12. And actually, I don't know why that's I. That should be h. Let's change that. Looks like I just typed the wrong thing. There we go. I was thinking inches when I typed that, but the variable is h. There we go. Much better. F equals h over 12. Here's another example of writing a function rule. The price P of a pizza is $6.95 plus 95 cents for each topping, which is represented by T on a pizza. So two things are varying: the total cost of the pizza and how many toppings it is that you're ordering. The independent variable is T, the toppings. That's what you're putting in there. And then the dependent variable is price P, the total price of that pizza. I cannot know the total price of the pizza until I decide how many toppings I want. So when you put that into an equation, the base price is $6.95 plus 95 cents times however many toppings I order. So if I got 5 toppings, it's going to be a little less than $5 plus the $6.95 for the, just your dough and your cheese and your sauce, just basically for a cheese pizza. You're adding for each topping, and that's going to decide the total cost of the pizza.